So, hello everyone. Today we're going to be solving a nice double integral, which is the double integral of xy dx dy over the area D, where D is an area which is defined by the following two equations. So dxy is equal to 1 and x plus y is equal to 5 over 2. So whenever you're doing a double integral problem, or a triple integral problem for that matter, what would be recommended to do is first graph the area over which you're computing the double integral over. So if I just do a sketch, I'll just go ahead and take our ruler. So I'm going to be graphing our standard xy coordinate system. This is the x-axis, this is the y-axis. And how am I going to graph these two areas, these two lines? So let's just start by graphing the first area. So xy, in the first line I mean, xy is equal to 1, therefore y is equal to 1 over x. Okay, so first thing that I want to find is its intersection points with the other equation, namely x plus y is equal to 5 over 2. So when I plug in 1 over x instead of y into the second equation, I'll get that x plus 1 over x is equal to 5 over 2. So I'm going to be multiplying both sides by 2x, and that will give me that 2x squared plus 2 is equal to 5x. In other words, 2x squared minus 5x plus 2 is equal to 0. So we have a quadratic equation here in terms of x. So we're going to have two solutions, two complex solutions, but I think they're going to be real. Yeah, so by using the quadratic formula, we get that x12 is equal to 5 plus or minus 5 squared, which is 25, minus 4 times 2, which is minus 16, and over 2a, which is 2 times 2, which is 4. So 25 minus 16 is 9. The square root of 9 is 3. So I'll get 5 plus minus 3 over 4. So our first solution is going to be 5 minus 3, which is 2 over 4 is 1/2. And our second solution is going to be 5 plus 3, which is 8 over 4, which is equal to 2. So in other words, when we go back to this equation right here, the y-coordinate for this x-coordinate is going to be 1 over 1/2, which is simply 2. And the y-coordinate for this solution is going to be 1 over 2, which is just 1/2. So we have two intersection points, let's call them A and B. A, 1/2 and 2, and B, 2 and 1/2. half. So I'm just going to try and sketch those two intersection points right here. So if this is 1, this is 2, then this will be 1/2, this will be 1/2, this will be 1, this will be, this here will be 2. So 1/2 and 1, 1/2 and 2, that's 1, that's our point A. And 2 and 1/2, this is going to be our point B. So again, I'm going to use the ruler to try and graph this out as accurately as I possibly can. Okay. This is also our line x plus y equals 5/2. And the graph of 1/x is already pretty well known. So it should look something like this. Yeah, something like this. So our area D, our region D, over which we're performing this double integration, or which we're calculating our double integral, is marked with red lines as such. So we can see, and this here of course is y equals 1/x. So now we can get to computing our double integral over d of xy dx dy, which will be the same as computing our x's. So what are the limits of integration here? So we can just rewrite this as integral of x dx to the integral times the integral of y dy. And what are our limits of integration going to be? Well, how do we solve this? Well, first we draw a line like something is falling on top of the graph. So, and what's the first function of x that we get to? So first we're going to hit a straight line, namely x plus y equals 5/2, from where we get that y is equal to 5/2 minus x. So that's going to be our upper limit of integration, and our lower limit of integration will be the other function that we have here, which is simply y equals 1/x. As for the x, we can just plug in these numbers. So x goes from 1/2 to 2. Now we've just completed the hardest part of the job, and now all we have to do is integrate. So we'll get the integral from 1/2 to 2 of x dx times y squared over 2, which is the integral of y dy, between the limits of 1 to the x and 5/2 minus x. And of course, this here part is going to be a function of x once we utilize the Newton-Leibniz formula. So we'll just put in dx right here. So we're going to get the integral, as x goes from 1/2 to 2, of x times 5/2 minus x squared over 2 minus 1 over x squared also over 2 dx, which is the same as the integral of 1/2 when x goes from 1/2 to 2 of x times, when using the binomial squaring formula, 5 over 2 squared is 25 over 4 minus 2 times 5 over 2 is 5 times x minus 5x plus x squared over 2 minus, this part here is simply going to be 1 over x squared, which is the same as saying 1 over 2x squared. Great. So I can pull out this 1/2 in front of the integral since it is a constant, and we're going to be left with the integral as x goes, and of course put the x here, from 1/2 to 2 of x times 25 over 4, which is simply saying 25x over 4 minus 5x squared plus x to the third minus 1 over 2x, and of course times dx. Now we'll get 1/2 of the integral. Okay, since this is pretty simple, pretty without the 2 here, sorry. Since this is pretty straightforward, I'm just going to compute the integral right now. So that's going to be 25x squared over 8 minus 5x to the third power over 3 plus x to the fourth power over 4 minus ln, the natural logarithm of x, between the limits of 1/2 and 2. So in other words, I'm going to get 1/2 times 25 over 8 times 2 squared times 4 minus 5 over 3 times 2 cubed times 8 plus 2 to the fourth power 16 over 4, which is just 4, minus ln 2. And then we're going to switch the signs right away. Minus 25 over 8 times 1 over 4 plus 5 over 3 times 1 over 8 plus 1 over 16 plus 1 over 64 minus ln of, okay, sorry, we're going to have a minus here and a plus here, minus here, plus here, plus ln of 1 over 2. Now we're going to solve this. So we're going to get 25 over 2 minus 15, oops, sorry, not 15, 40, minus 40 over 3 plus 4 minus 25 over 32 plus 5 over 24 minus 1 over 64 plus ln of 1 over 2 minus ln of 2. Now the common denominator for this part right here is going to be, now when you compute this further, the common denominator is going to be, okay, 96, not 96. It's going to be 96 times 2, which is the same as 2, 18, 192. Divided by 2 is 96 times 25 is 2,400 minus 192 divided by 3 times 40 minus 2560 plus 4 times 192 plus 768 minus 192 over 32 is 6 times 25 minus 150 plus 192 divided by 24 is 8 times 5 is 40 minus 192 divided by 64 is 3, and of course plus ln of 1/2 minus ln 2. Actually, let me just rewrite this as well. Ln of 1 over 2 can be rewritten as minus ln of 2, and this is then equal to 1/2 times 2400 minus 2560 plus 768 minus 150 plus 40 minus 3 is 495 over 192 minus 2 ln 2, and we can actually simplify this rational part, this fraction here, which is going to be, both of them are divisible, 495 and 192, both of them are divisible by 3. This here is going to be 165, 192 divided by 3 is 64. Which is the same then as 1/2 times 165 divided by 64 minus 2 ln 2, which is the same as 165 over 128 minus ln 2. So, in conclusion, the double integral over our given region D of xy dx dy is equal to 165 over 128 minus ln 2, which concludes our today's video. So I hope you enjoyed it. If so, hit that thumbs up button and hit and subscribe. Thanks for watching. I'll see you in the next video.